Welcome to the GCP Networking Practice Series from the AI Mock Interviewer Question Bank. GCP Networking Part 1. This episode has 12 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Networking. GKE troubleshooting. A critical service on GKE has intermittent 5xx errors during traffic spikes. Walk me through your debugging approach from load balancer to pod level metrics. Here's a strong way to approach it. Check load balancer backend health and latency metrics first to see if the errors originate there. Unhealthy backends during a spike, often from insufficient replicas, versus at the application layer. Check HPA scaling behavior. If pods aren't scaling fast enough to absorb the spike, requests queue and timeout. And check pod level CPU or memory saturation and any connection pool limits. Database. Downstream services. That could be the actual bottleneck once traffic exceeds current capacity. Nice. Let's continue. Question 2. GCP services. Cloud Run Security. How would you expose an internal Cloud Run service securely using IAM, ingress settings, VPC connector, load balancer, and service-to-service auth? Here's a strong way to approach it. Set Cloud Run ingress to internal and load balancing so it's not reachable from the public internet directly, and require IAM authentication. Not all users, so only explicitly authorized service accounts can invoke it. Use a serverless VPC access connector if the service needs to reach VPC internal resources, and for service-to-service calls. Use signed ID tokens from the calling service's identity so the receiving Cloud Run service can verify the caller's identity rather than trusting network position alone. Great. Moving on. Question 3. SRE or reliability. Pub or sub incident. A downstream service outage caused pub or sub backlog. How would you recover safely without overloading dependencies or losing messages? Here's a strong way to approach it. Let messages accumulate in the subscription. Pub or sub retains unacted messages up to the configured retention period, rather than dropping them, and once the downstream dependency recovers, ramp consumer concurrency up gradually rather than processing the entire backlog at max speed immediately, which could overwhelm the just recovered dependency again. Monitor the downstream service's health metrics during backlog drain and throttle consumption if it shows signs of stress, and verify no messages were lost by checking the subscription's message count trends before and after. Alright, next question. Question 4. Security or DevSecOps. GKE expert. You are asked to design a production GKE platform for multiple product teams. How would you structure clusters, node pools, namespaces, IAM, networking, and deployment ownership? Here's a strong way to approach it. Use a shared cluster per environment, or region, with namespace per team isolation enforced by resource quotas, network policies, and RBAC scope to each team's namespace, rather than a cluster per team unless strong isolation genuinely requires it. Structure node pools by workload characteristics, general purpose, GPU, spot-tolerant batch, shared across teams for efficiency, centralize networking via shared VPC, and give each team ownership of their namespace's deployments through GitOps while the platform team owns cluster-level configuration and upgrades. Let's keep going. Question 5. GKE or Kubernetes. Commitment planning. How would you decide whether to buy committed use discounts or reservations for GKE or compute workloads? Here's a strong way to approach it. Analyze historical usage trends to identify the stable, predictable baseline load, a good candidate for committed use discounts versus the variable, spiky portion, better served on demand or with spot instances, and commit only to the baseline you're confident will persist for the commitment term, since overcommitting locks in cost without the usage to justify it. Review commitment utilization regularly and adjust future purchases based on actual growth versus forecast, treating it as an ongoing FinOps practice rather than a one-time decision. On to the next one. Question 6. Observability. OpenTelemetry. How would you roll out OpenTelemetry across services and connect traces, metrics, logs, dashboards, and alerts? Here's a strong way to approach it. Roll out incrementally starting with the highest traffic or most operationally important services first. using auto-instrumentation where available to minimize per-service code changes, and standardize on consistent resource attributes, service name, version, environment so telemetry correlates correctly across services. Route all signals through an open telemetry collector to a unified backend so traces, metrics, and logs can be correlated by trace ID, and build dashboards or alerts on top of that unified data rather than maintaining separate, disconnected tooling per signal type. Good. Here's another one. Question 7. Networking. Cloud DNS. A production service intermittently resolves to an old endpoint. How would you debug DNS TTLs? Cloud DNS records, caches, split horizon DNS, and client behavior. Here's a strong way to approach it. Check the actual TTL configured on the DNS record first. A long TTL means clients and resolvers legitimately cache the old value for that duration after a change, which is often the real cause rather than a DNS bug. Verify the cloud DNS record itself is correct and fully propagated. Check for split horizon DNS misconfiguration if internal and external resolution differ unexpectedly, and check client-side DNS caching behavior. Some client libraries or OS-level resolvers cache more aggressively than the TTL suggests as a separate layer to rule out. Nice. Let's continue. Question 8. GCP services. AlloyDB design. When would you choose AlloyDB over Cloud SQL? And what operational considerations would you discuss for HA, backups, scaling, and cost? Here's a strong way to approach it. Choose AlloyDB when you need significantly higher performance for PostgreSQL compatible workloads. AlloyDB's columnar engine accelerates analytical queries substantially, or need better read scalability with its read pool architecture. Choose Cloud SQL for simpler, lower-cost workloads where AlloyDB's added capability isn't needed. Operationally, both support automated backups and HA configurations, but AlloyDB's architecture, separating compute and storage, changes how you think about scaling reads independently of writes, and its cost profile is generally higher, so the decision should be justified by an actual performance or scale requirement, not used as a default upgrade. Great, moving on. Question 9. Networking. VPC fundamentals. Explain VPC in cloud networking. Here's a strong way to approach it. A VPC, virtual private cloud, is a logically isolated, private network within a cloud provider where you define IP address ranges, subnets, routing, and firewall rules for your resources, giving you the same conceptual control as a traditional on-premises network but implemented as software-defined infrastructure that scales globally and integrates with the provider's other managed services. Alright, next question. Question 10. Networking. Public versus private subnet. What is the difference between public and private subnets? Here's a strong way to approach it. A public subnet's resources can have public IP addresses and are directly reachable from, and can reach, the Internet. A private subnet's resources have no public IP and can only reach the Internet outbound through a NAT gateway, with no direct inbound path from the Internet. Private subnets are the default choice for anything that doesn't need to be Internet-facing, minimizing exposed attack surface. Let's keep going. Question 11. Networking. Routing fundamentals. Explain routing in a cloud network. Here's a strong way to approach it. Routing determines the path network traffic takes between subnets, VPCs, and external networks. Cloud VPCs come with implicit routes for local subnet traffic, and you add custom static routes, or use dynamic routing via BGP with Cloud Router, for traffic destined to external networks, other VPCs, or on-premises systems, with the routing table ultimately deciding which gateway or next hop handles each packet based on destination IP. On to the next one. Question 12. Networking. VPN connectivity. How does VPN connectivity work between on-premises and cloud? Here's a strong way to approach it. A VPN gateway on the cloud side and a compatible device on-premises establish an ISEC tunnel over the public internet, encrypting traffic between the two networks so private IP ranges on both sides can communicate as if directly connected. Routes, static or dynamic via BGP, determine which traffic is sent through the tunnel. and redundant tunnels or gateways are typically used for high availability since a single VPN tunnel is a potential single point of failure. Good. Here's another one. That wraps up this episode. Nice work practicing, and see you in the next one.